So thank you all for joining. I want to now introduce Rafael. He's an old friend and colleague for the past, I guess, 15 years. We've worked in the space of quantitative risk analysis. Both of us worked for Palisade in different positions for many years, and then subsequently gone on to form Ferryfield, which Rafael works with us as a partner, and he's the director of his own organisation, Imagine Risk. We both help promote Safran globally, do training and consulting, and resell the products in different regions. Because Rafael's out in Brazil and Ferryfield's based in various other countries. So thank you all for attending. I'd like to hand over to Rafael now for his session on his masterclass session on data centers.
Thanks, Craig. Thanks everyone for joining us. And I hope we can have an interesting and fun session, okay? So the idea here is to present how Safran Risk works in the environment of data centers, which is a new kind of construction project that we're seeing more and more. According to the latest data, the GDP of the US is being pushed by this kind of construction projects, for example. And there are some peculiarities of this kind of project that I would like to discuss here. And of course, every single project is unique. Every single project has their own environment, their own specific risks. But I hope I can show you that it's easy to, after you, of course, understand and assess and evaluate the risk, it's easy to quantify its impact using Safran Risk. That's the idea, what I plan to show here today, okay? There's going to be very little focus on the PowerPoint. We're going to focus on the software itself. I hope we can settle the whole thing in 45 minutes or so, the presentation itself, so that we can have a Q&A session and we can discuss questions and if you have anything specific at the end of the event, okay? So, of course, there's a PowerPoint just to guide us through the topic, the main topic, but we're going to focus on the software itself more and more, okay? Try to make it very practical. So my name is Rafael. I've been working with risk analysis for more than 2 decades already. I have experience in many different industries, many different countries, more than 20 countries that I've already worked at. And I do a lot of consulting and training work using many different risk software. And Safran is the one I use the most nowadays for schedule risk analysis. Schedule and cost, actually, when you're dealing with projects, right? Even though risk analysis can be a lot more stuff than schedule cost, you can do financials, you can do economics, you can use it to price derivatives. There are many different uses of risk analysis. Here we're going to focus on the schedule and the cost of a specific project, okay? And what is Safran Risk? What is this tool that we're going to use here to quantify the risks of our project before we jump into the project itself? Safran Risk is a specialized tool, a specialized software tool for risk analysis of schedule and cost. It runs Monte Carlo simulation on top of your schedule, right? We specify the schedule of the project, we specify the costs, other things such as resources, etc. Everything related to the schedule and the cost, we specify that first. Then we list the risks that we believe might impact your project in terms of probability, in terms of impact, in terms of which tasks or which costs will be impacted by that specific risk, okay? And then we run the Monte Carlo simulation. And Safran offers a platform for you to do all of this. Even if you want to build your schedule from scratch in Safran Risk, you can do that, okay? Although we can also work with Primavera P6, Microsoft project. But it's a platform for you to model and quantify the risks surrounding your project. There's all kinds of details. We could take 2 or 3 days if we wanted to cover the whole software and all the details that it has, all the options that it has in terms of modeling capabilities. But the cool thing is that it's very intuitive, extremely user-friendly. The interface is very easy to navigate, to find your stuff, and to understand what you're doing, and to find ways to model precisely what you want, the way you want. For example, if there's a risk driver, there's a certain event, external event. If it happens, it affects many of your tasks simultaneously, such as a spike in the exchange rate. It will affect many of your costs simultaneously. Or a problem with the contract of a specific supplier, a specific EPC company, for example. If that contract runs sour, you're going to have many tasks of your project delayed simultaneously. It's easy to model that. One click, you do that specific thing, one risk that affects many things simultaneously. Or if it's a risk that may affect many different things, but one at a time. Maybe it's a risk that repeats now and then, such as raining. Maybe if it rains when you're doing something, that task will be delayed by 1 or 2 days. But the other task that comes right after won't be delayed. It will start delayed, but the duration itself will not increase because it rained last week, right? So things such as rains or accidents or things related to efficiency, they are not really a single risk, but it's a multitude of similar risks that we bin into a single bucket, into a single name with specific parameters. But when it occurs, it might occur for one task and not for the other. There are ways to model this within Safran Risk, also very easy. We're going to see how we can distinguish those tasks and model them accordingly within the software. Okay, so the interface is extremely user-friendly, has many functionalities to help you identify and manage risks, allows you to model all types of risks, and so far nowadays it's the best tool that I know that I use for schedule risk analysis, for schedule and cost. When I see the interface, I think there are some brilliant ideas that they had when they created the software that makes it really special. Okay, we're going to see those along the way. So it is compatible with Primavera P6 and Microsoft Project. As I mentioned, we can import, you can start your schedule from scratch if you want, or you can import a schedule from this tool. Those are the most commonly used tools for deterministic, for planning schedules, right? You can also import the risk model from the old Primavera risk analysis software, which has been around for a long time. It's now declining in use. Fewer people using it because of the legacy issues and even IT security issues that it has. So fewer and fewer people using Primavera risk analysis, but still a lot of people using it. So we can import the model, I think it's RNX, the file extension that you can save from Primavera risk analysis. You can import that into Safran Risk, and then you have your model halfway through, almost ready to run the analysis. Okay. It also allows you, it brings you a lot of stuff in terms of visualization. The typical histogram, cumulative curves, tornadoes, etc. But it also brings some new stuff such as scatter plots using joint confidence levels, probabilistic cash flows, the way it maps the critical path and creates maps for you. There is not a single critical path, but there are many possible critical paths. One activity may be within some critical paths and not in others. One activity may be X% of the time on the critical path. So it helps you visualize all of that so you can make better decisions, better planning, better control, okay? And it's focused on complex projects, especially capital-intensive industries such as oil and gas, construction, mining. These kind of industries use Safran Risk a lot. And now we see data center construction EPCs also using Safran Risk to bring up from scratch their projects. So it's the ideal tool for organizations seeking a comprehensive view of risks, combining both accuracy and modeling capabilities with the ease of use, okay? Now jumping to our topic at hand, data centers. We're going to talk here about schedule, cost, and risk, okay? It's an example project, of course, not with real numbers for confidentiality issues and all that. But the idea of the project, of the structure of the schedule is of a typical data center construction project. The scope of a project like this is of our analysis, I mean, is the construction schedule of the data center from the planning to the commissioning and delivery of the building, right, of the project. We're going to have phases related to our tasks related to planning, to licensing, engineering, design, project, right? Procurement, construction, delivery, installation, assembly, commissioning, electrical power, We also have some tasks related to cooling the whole system, right, which is very important in the data center. And we're going to be considering the schedule, the costs, and all the risks. One thing that's interesting about a data center, about what we see in terms of construction, most of the time, the way people plan the schedule, the way people discuss the schedule and the costs are really important, but we rarely talk about resources. From the execution point of view, it's very similar to a construction project. And usually resources are not at a very high level of detail when we're talking about planning, about even the deterministic schedules that we see. So resources are not really the focus. That's what we see in practice. If you look at other industries such as oil and gas, then resources are a big thing because there are some resources that carry the load of 20 or 30% of the whole cost of the project. If it's a drilling project, offshore drilling project, the drilling rig is the big resource they have that drives the whole cost, and also that where they have to plan for a bunch of schedules using the same resource, sometimes a bunch of different projects, a portfolio of projects sharing the same resource back to back. So the resource is very important in oil and gas, in some other industries too. Here in data centers, I believe my perception is that the projects seem more like a construction project, but it has a few specific risks that we have to take care, and which are usually not present when you're talking about a construction project. So it's a very unique kind of construction, okay? What are the risks that we're gonna model here? We're gonna model in our case here. Uncertainties in schedule and costs, so variability of the planning assumptions, like you plan on building something or run your procurement phase in 90 days, but it might take 100, 120, 150 days, depending on problems along the way. So there is an uncertainty, a natural variability of the assumptions. This is one source of risk. Another source of risk are risk factors that may come up and disrupt your project, such as reworks, construction risks, supply chain problems, issues, problems with your permits, problems with, let's say, accidents, things that are pretty much internal to your project, okay? Within the ring fence of the project, events may occur. And also we have external risk factors, such as the weather, inflation, cost escalation, macroeconomic problems that may occur. We've seen now with the Ukraine war a couple of years ago when it started that many prices went up. Some of them went through the roof, actually, some costs, and stayed there. It's been like this for a long time. Now we have the US tariffs, Trump tariffs that might affect both the availability of some things, equipment, resources, and their costs, okay? So these external risk factors, they can be accounted for. They should be accounted for in a project like this, okay? So I have at least three sources here of risks. Variability, which is natural. Even if nothing happens, even if there is no event, there will still be variability, either because you do things differently from what you planned, or because you can't foresee everything perfectly when you are planning. So there is variability. Okay, there's no way to run away from this. Internal project risk factors, things that are part of your project that may require rework or some extra cost or time to perform. And external things that are not even part of your project, but may affect your project, okay? Now, we're gonna look at the model in a second, and we're gonna discuss some typical risks that a project like this faces. But typical risks on a data center project would include duration, risk, uncertainty in the schedule, right, and the costs. Supply chain risks, events related to the supply chain. There's a lot of equipment that you may be purchasing from abroad that you will be procuring from abroad. So supply chain problems, either delays or costs or exchange rates, things that might affect your supply chain, okay? Product specification, quality. It's not only schedule and cost, but many other things that end up impacting schedule and cost, okay? Environmental permits, this could even be on the specific list below. environmental permits. We all need environmental licenses for our projects, right? No matter what the country you are, no matter what you are building, environmental licenses are necessary. We have to comply with usually many different environmental rules, okay? But for a data center specifically, you are within the city. You are probably building the construction site is within the city limits. So that's a very specific case, just like building a construction or like a regular building within the city. That makes it a little bit different from like oil and gas, mining, where you are usually working outside the city. That helps on one hand, but also is detrimental on another side, looking from another point of view. Because if you are within the city limits, there are some extra things you have to worry about in terms of pollution, noise, and some other things that might be a problem. The environmental permits within the limits of the city might pose some additional risks to the project, okay? You also have external risk factors. Those are typical risks that a project faces. Weather, macroeconomy, cost escalation, inflation, exchange rates, etc. Okay. Now, specific risks that make a data center project unique, in my opinion. First of all, the use of energy and water. This is something that we are seeing in the news all the time, and there is technology available to build your data center project with no use of external water. You can build a data center with a closed loop circuit, a closed loop water circuit. So you require no external water. That is very relevant. It makes your project a little bit more expensive from the procurement point of view, from the design point of view, but that is very relevant specifically if you think about the company and the project image. Now, the data center project is probably being built within the city limits. So your interaction with the communities around you, the interaction of the project, even when it's not even on the planning phase, the interaction with the community is very important. The community watches the same news that you watch, so they know about the water use, they know about the energy use. Some communities will face water shortages because of data center projects. So that's a very big risk, both in terms of image, but also in terms of you may have strikes, you may have problems with the municipality or the federal government or some government agency because of pressure mounted by the community. So those specific risks are things we have to account for on a data center. It's not just a construction project, walls and chillers and energy, a lot more than that, okay? And a project like this has a lot of visibility nowadays. It's on the spotlight, it's on the news all the time. So it's something we have to consider. The energy use is another thing, both from the technical point of view, because the project will require a ton of energy. So you need a reliable energy source, but also from the point of view of the communities, because you may be increasing the cost of energy, your project, if it's too large for a small community, it may be increasing the cost of energy for that community. So that's a risk to your project. The engagement of the community is a risk to your project. Maybe the company image will be tarnished by the relationship with the community. So we're even talking about things that transcend here the schedule and the cost itself. But all of those, communities, use of energy and water, all of those might affect your schedule and the cost too, okay? And also beyond. So those are very specific risks that we have in data centers. Energy and water, the image of the company and the project, and interaction with communities. Of course, if you're dealing with a mining projects, for whatever reason, we are unlucky to have mining projects, usually on a very pristine piece of land, pristine piece of forest. So communities are always a thing on a mining project, yes. But I don't remember a mining project worried about the use of energy, for example. Water, yes, it's a big thing in mining too, but energy, it's usually not a big deal. Oil and gas, well, we don't care about energy in an oil and gas project. It's supposed to be supplied either by the oil you are producing or the gas you're producing or coming from outside. It's usually not an issue, energy. Even water is very well managed in oil and gas projects, right? Of course, there's a pollution thing that might affect water, but we don't talk about water in an oil and gas project most of the time. Here, it's very big, this thing. And also the company image, right? If you don't deal well with the communities, you may even face some kind of fatal risk for your project. Maybe the government agency will look bad upon you or whatever. So I have to be very careful with those. Those three risks will affect your scheduling cost, but will affect a lot more than just that, okay? We'll see how we can model some of them within our project. So those are the typical risks and specific risks that we face, that we have to deal with when modeling a data center project, okay? So now let's go into the software and let's do the analysis step by step, okay? So basically in 7 steps, we can go from scratch and build our risk analysis model in Safran Risk, okay? We'll start by importing the schedule, then we'll look and edit whatever is needed in the schedule itself, if there's anything we need. There is a schedule audit tool, some warnings that we'll face if your schedule is not mature or if your schedule has issues that might affect your risk analysis. Safran will tell about that. We can check those. Then we model all the risks that we deem important, relevant for the project. We model, there is a risk matrix within the software where we'll model costs, correlations, even mitigation strategies. There's a risk mapping interface where we will make the connection between risks and activities, tasks, costs within the project. Then we run our Monte Carlo simulation itself and analyze the results, which is the most fun part, of course, analyzing the results. So in 7 steps, you go from a schedule that you have in Primavera, P6, or Microsoft project, and you end up with results that you can understand, report, present, etc. Okay? Let's take a look at the software itself. So I'm not gonna spend more time on the PowerPoint. Let's go into the software itself. So here is the software, Safran Risk. I have already imported my schedule, but if you wanted to import a schedule file, you can do that here on the Import External Project File button. Safran has a scheduling tool called Safran Project. So if you're using that, you can import Safran Project files directly, or if you're using P6 or Microsoft Project, you can import the P6 or Microsoft Project files here using the External Project Importing tool. I've already done that. Our project is already here. Data Center Project, I'll open it. So after we import your schedule, I would jump through the topic of importation because it's pretty straightforward, okay? But what you get here once you import your schedule is you have a full scheduling tool here that we can use to either understand or change your project, okay? For example, I can take a look at my tasks, the specified duration for each, start and finish dates, preceding, succeeding tasks, costs. It's calculated the flows for me. If I want any other kind of information, I could add another column here and customize this as I wanted. For example, percent completion, whatever I needed here, I could, customize the interface as needed to include the information that I would like to see. This interface is a typical scheduling tool. You have your Gantt chart here on the right side. Okay, let me just make the Gantt chart here. Here's my Gantt chart. If you want to look at activities, for example, let's see which activities are connected here to this one, environmental studies. So land acquisition comes before environmental studies, and the succeeding tasks are technical studies and permitting. So you can see the characteristics of each of your tasks, either information about the activity itself, what it's linked to. If you're using resources could be mapped here. They could be loaded according to whatever profile you need, okay? Histogram of use of resources, etc. So it's a complete scheduling tool that we have here. And at this point, after importing, we usually check if things are as expected, if there's anything missing or any number that is different for whatever reason. We could check that and correct whatever is needed. The next step after importing and viewing the schedule is taking a look at the schedule warnings. There are some warnings in this rotation here in this project. For example, some of them related to relationships. So there's an activity with no predecessor. Well, it's the first activity of the project. That's okay. There's also an activity with no successor. Yeah, also the final project handover, so that's okay. There are some activities here in the middle which have no successors, and that is weird. For example, environmental permits are not connected to anything else. So if they get delayed, nothing's going to happen in my project because no other task is waiting for this one. No other task is connected to the end of this one. So this is weird. I should check if this makes sense. So environmental permits here, task 122. It should be connected to something, right? And it is not. There's no task. When I look at the links here, there's no succeeding task. So you should correct that. For example, I could say that these permits are needed for, so 122, I'll say it is needed, let's say, for earthworks. So before I start earthworks, I need to have all my permits allocated, correctly assigned. So I will add a new predecessor here just to fix that, okay? It's important that we follow through with these checks so that our schedule makes sense at the end. So now that warning is gone. I have only 6 warnings left. Roofing and waterproofing is also unconnected. So that is task 148. It's very important that we take care of this. Otherwise, your risk analysis might calculate numbers that don't influence each other, right? It's important that this makes sense. So as you can see here, there is a single task before roofing. And interesting, it's not connected to a specific task, but it is connected to the next phase. So it's telling me that I have no successor, which is true. But at the same time, this phase here requires that the previous phase is finished. So it is okay. I can leave roofing like this. I need roofing and waterproofing ready before I start commissioning stuff. You could be more realistic and think that you need roofing before you install electrical systems, right? So yeah, I will add here a successor to make sure that roofing is a requirement for 150, for example, which is actually even for 149, which is equipment platform. So we require that we finish roofing before the main equipment platform is performed. So now they are connected. I have to be careful with this. You have to make sure that your tasks are correctly assigned. The other tasks that we have here, they face the same situation that they need to finish so that phase 5 can start commissioning and handover. Okay. So this is a very important step. We're not even started with the risks, but it's important we have a decent, a mature schedule for that. Now the fun part begins. We will talk about the risks themselves. Okay. As you can see, there's a risk matrix here, the typical list of risks with probabilities. There are some risks that I already assigned here, risk 1, 2, 3, with their nicknames and a short description, okay? All of these risks, they have a probability of occurring or not, and they have a type, okay? After I specify the kind of risk that we're talking about and the probability, we can specify here on the right side the impact. And then on a second step, we will map which risks connect to which activity. This is a very interesting part of the interface because it's very graphical and you can easily map risks to activity in a user-friendly graphical interface. That helps a lot, okay? So let's take a look at the simplest ones here. Uncertainty 1 low. This is what I'm calling here. This is the nickname for my variability, what I'm estimating in terms of variability of tasks. And some tasks have a low uncertainty, some tasks have a high uncertainty. What do I mean by that? Well, first of all, this kind of risk is not a standard risk with a probability of occurrence. It's an actual estimate uncertainty. What I'm talking about here is that there's 100% chance that things will be a little bit different from what you planned. This little bit is what we're measuring here. It's what we're mapping here. The natural variability of things. And things always, end up a little bit differently from what you planned, from what you estimated. even if there is no external event. If you look at the other thing here, for example, risk number 1, critical equipment delivery delay. This is a standard risk, which means it may occur or not. There's a probability that it will occur, 30%. And if it occurs, then there's an impact. If it does not occur, there is no impact. The added duration or cost is just 0. So the first thing we do here in the software, we separate what is variability from an actual event that may occur or not with a probability. There are some other kinds of risks, such as the risk the task existing or not, or the non-existence of a task. Very useful when you're dealing with prototyping, things like that. Probabilistic branching, sometimes you're mapping decision gates and your project may go one way or another. Some companies, for example, large companies, public companies that work with bidding processes, they create a schedule for their bidding process, right? When they're procuring equipment or large plants, things like that. And in the risk analysis of the procurement process, of the bidding process, they include some probabilistic branching rules. For example, if there are less than like 3 candidates, they will need to start the bidding process again for a longer time to attract more, companies, more competitors. Sometimes there are rules in the law that require you to do that. Or if the bidding process goes all right, the project goes one direction. If the bidding process goes another way, you can sometimes hire a company outside of the bidding process because there was no competition. So you're excluded from the bidding process. A probabilistic branching works nicely. It's the correct tool to model this kind of behavior within the schedule, okay? Sometimes you don't know whether you're going to hire company A or B to do something. So probabilistic branching works with that. And also we have calendar risk. I'm going to model weather here in a very simple, straightforward way, which is enough for this case. But if you have a calendar or a weather intense situation, environment, for example, if you are not building a data center in the middle of the city, but if you are building something in the Amazon forest or in a very unique environment where the weather plays a major role, like offshore drilling or mining into the forest, and the calendar plays a major role in your efficiency or on the availability of resources. So we can map, the risks according to the calendar. There's an interface on the software, you can do that, okay? But most of the risks we're gonna model are either estimate uncertainty or standard risks, where you have a probability of occurring or not, okay? So starting with the uncertainty here, so I map things with low uncertainty in my project. I map in them like this, 100% chance that things will vary a little bit, right? And this little bit means on the pre-mitigated position here, every single task that I assign as low uncertainty will face a plus minus 10% variation. So it's going to be a relative variation on top of whatever duration the task has. If it's 10 days, it's going to be plus minus 1 day. If it's 1,000 days, it's going to be plus minus 100 days. Okay, so a variation around the center, around the most likely. This is the schedule impact of this risk. But this risk, when it happens, it also has a cost impact, also plus minus 10%. So whenever I run the project, whenever the project is simulated, all tasks that belong to the low category, they're going to have a small variation in their duration and a small variation in their cost, okay? And here below, I have the list of tasks that are affected by this category of risk, okay? By this risk. We can also assign, if you want, post-mitigation probabilities. So let's suppose we have a mitigation strategy for this specific thing. We can apply an action with a cost, a time that consumes a time spent mitigating this risk. And then the schedule and the cost impacts might be different from what we have here on the pre-mitigated position. So we have the risks always mapped. You can have the risks always mapped as pre and post mitigated, okay? We can also correlate the impacts of the different risks. We can correlate the existence. There are some things regarding correlation that we're not going to discuss here. There's even a correlation matrix if you want to go that deep, okay? Now, the other kind of risk I have here is high uncertainty. So high uncertainty means very little chance of making it any faster or any cheaper. And there's a good deal of increasing cost that might be faced, okay? So up to 50% increase in duration and cost. So that's what I mean by high uncertainty. And then there are some tasks that I classified as high uncertainty, like functional testing, systems testing, the initial permits that usually take a lot more than what we aim for, right? The critical equipment bidding process. So some things that are more critical that sometimes deviate a lot from what we plan. Those are the ones I'm calling here high variability, okay? And how do I map those to my project? On the risk mapping screen, I have here the list of risks that we face, and the list of tasks of our project through the rows. So all tasks are here, and also the list of risks that we mapped, that we modeled here as columns. So I'm saying that, for example, low risk, this task here, initial project planning, this is low risk. Land acquisition, also low risk, easy, right? Main contracts, easy. We know how to do that. Piece of cake, we do that all the time, low risk. Now, permitting, that's a high variability task. This may take a lot longer than what we aimed for. We're doing the best efforts to make it fast. This thing should actually take, according to the information I have here, this thing should actually, where is information? This thing should actually take 25 days. But based on the risks that we mapped here, there's a high variability risk. And there was also a second risk mapped to this one, permit problems. So not only it varies a lot, but sometimes you have to apply for more permits or have to rework the permits 2 or 3 times. So these are the 2 risks that this specific task faces, variability, and there's one here called permit. And this is what the final duration of the task will look like. A very quick simulation, still outside of the Monte Carlo simulation, is just a briefing of how the risk will look like. So something that should take 25 days might take up to 100 days if you're not lucky. Of course, the likelihood is very small here on the right, okay? Most of the time, it's going to take the average about 38 days, okay? So it's going to be around maybe 40 plus minus 10, but it can reach 100 days. So this is what this task will look like during the simulation. And then, of course, it will affect everything that comes after that and the snowball effect that we have on a schedule. Coming back here to the project risk. So another risk that, let's talk about this one. Number 2, permit. Environmental permit issues. It's a standard risk. I think there's a 50% chance of facing a major delay on this. Not only a slight variation of almost 50%, but a major delay, like it can take 3 times longer to issue the permits. No impact on costs. I don't think there's any impact to the costs. I just wait longer to get the permits, and then if anything needs the permits, it's going to be delayed after that, okay? There are 2 risks that face this 2 tasks that face this risk. Now, here's another thing that's very interesting about the software. When I assigned a category like this, environmental permit issues, it's a big impact, right? It's a very big risk. When this thing happens in my project, should it affect the 2 tasks that I mapped here simultaneously at the same time, or should this be 2 different distributions from this category affecting these 2 guys, these 2 tasks independently? We can make this risk impact all of the mappings here simultaneously, or we can make it affect them independently. So if I turn this option off here, impacting the independently is off. When this risk happens with its 50% probability, it increases the duration of these 2 tasks simultaneously. Both of them will suffer greatly and jointly. Now, if I believe that this is just a category, maybe some permits will be delayed, but the other permits will be okay. I have 2 phases in my project where I, apply for environmental licenses, where I go after my permits and licenses. I'm talking about a risk that may occur at either of them, or at both of them, or at none of them. So it's an independent risk. So we have the option to make risks that affect many things, such as, let me see one that affects many tasks, like this one. Construction material cost escalation. If there's cost escalation, maybe I'm considering that this is exchange rate. If it costs more, it affects everyone. Or I'm talking about specific industries or specific cost escalation. Maybe these things are coming from different countries. So you can apply the risks either to all of the tasks simultaneously or independently. Now, if I flag here independently, this single line here, risk number 4, it is actually representing 1, 2, 3, 4, 5, 6, 8 risks. One line on my matrix representing 8 different risks that may occur or not independently. Maybe all of them simultaneously, very unlikely, but it could, right? But it's 8 things versus if I tell the software to apply as a single risk factor that affects many things simultaneously. Now it's a single risk affecting them all. Of course, this has a major impact on the results we see at the end, okay? So by assigning the risks from our risk matrix, from our qualitative risk work, right? By assigning a probability and a distribution to each, or even 2 distributions, right? Schedule and cost. We can then map on the next screen here, map which activities are impacted by each risk. So as we saw, the uncertainties here, high or low, or maybe none. Maybe there are some activities that have no uncertainty at all. It's guaranteed, the deadline, the cost, whatever, okay? But first assign the variability to each, and then here on the right side, we will assign which activities actually suffer or are subject to each specific risk. So for example, let's see one here that affects many. I have one here this one. So weather. Weather affects here earthworks, structures, foundations, shallow foundations, structures, and assembly, fabrication and assembly. So weather affects many different things, okay? It's a risk that we mapped here. There's a 25% chance that I would see some kind of weather event, either raining, flooding, wind, fire, whatever, right? 25% chance. It might have an impact on my schedule and on my cost. The impact on my schedule in this case is not a relative number. It's not a percentage. It's a number of days that I delay. So I may delay my task in 5 or up to 20 days because of this event. And it is an independent event. It might happen, it might rain when I'm doing the earthworks, but not rain when I'm doing the foundations, for example, okay? So it's independent. So here in the risk mapping, many different tasks impacted by this risk. So if you look here, structures assembly, for example, is affected by weather. It's affected by existing utilities. You may have problems concerning existing utilities, like a pipeline or something. It's a low variation risk, so there's also a tiny variation here because of the uncertainty. And also risk 4 here, cost escalation, has no impact here on the schedule. This is the distribution we would see after the simulation for this duration. Same thing for the cost here. I have 4 things affecting the cost, and then 4 risks, right, affecting the cost, and then this is the distribution we'll see at the end. So these 2 interfaces, it's where we have fun assigning the risks, creating the risk matrix with probabilities and impacts, with all the details that you need for assigning risk factors independently, simultaneously, correlations, etc. And on the risk mapping, then it's a point-and-click work of assigning which risk to which task, with all the information that you need to make a good job here. And the interface helps you in a lot of things. You can see the schedule impact, the cost impact, which risks are affecting what. We can also specify if the risks happen in series or if they happen in parallel. So when weather events occur and I find a pipeline, existing utilities occur, do they happen simultaneously, they overlap, or do they happen one after the other? Well, in this case, they happen in series. The variability also in series. Maybe cost escalation should be something that I put in parallel. You can assign here with the level of detail you need, what are the risks that happen in parallel or in series with each other. Risks that happen in parallel, you will get the worst result from both of them. If they're happening in series, they add. So the worst case scenario is a lot worse than when it's in parallel. So here you can even specify that, okay? Now, moving on, you have here all the details. Moving on to the next step, which is project risks. We assigned all the risks from our matrix. We made this connection between risks and activities. Now we're going to analyze, run the Monte Carlo simulation itself. So here in the Analyze tab, we're going to run the simulation. Now, another very nice thing of the interface that people really love when they start using the software. First of all, you can run the whole thing pre-mitigated, or I don't have anything here post-mitigation, but if you had, you could run your project post-mitigated. Or you could perhaps mitigate just 2 or 3 of your risks and run an intermediate scenario, okay? If you want, you can also measure impact of things or test ideas by simply turning off a given risk. You can turn off 1 or 2 risks, simply unflag the risk, and when you run your analysis, you will see the whole thing without that risk. It's a very quick way to test ideas, even if you don't know what the mitigation is. But if there is a mitigation that you could put in place, you can easily calculate the impact of going after that. You know, remove the risk, run the model again, and see if it matters for your KPIs. Okay, if it matters, then let's have this discussion about how to mitigate this risk. If it doesn't matter, if it is simple test, you see no benefit of mitigating the thing, so you can skip this one and talk about the next problem that we have, okay? That's a very quick way to test ideas, scenarios, either pre-post mitigation or with or without specific risks, okay? There's a lot more to that in the reports too. But we'll run the simulation now real quick. Just before I go, I'll turn on here the step through function, which shows you the analysis happening in real time. So with step through, you can actually see the schedule being calculated here. You can see the delays happening. So on this scenario, there was a huge delay from what was proposed here, the shadowed deterministic marks. We can see that the actual, simulated result is a lot longer the duration of the project than what we aimed for at the beginning, the deterministic sense. So you can see the project running here. You can see that for duration, for cost, whatever you're looking at, you could check this. I'll just complete the thing real quick. As you can see, the software is pretty fast. And then here we have the results. So this is the finish date for my full project, the delivery date of the last milestone, the last task of the project. The deterministic idea was to finish it by October 5th. Well, that's not going to happen. It's very, very, very unlikely. Most likely we'll finish around January, or to be more, conservative, we should aim for March. There's a 90% chance that we finish up to early March. Only 10% chances that we slip, and then you could slip even 2 more months. As you can see, it's a very large distribution, very wide distribution. Also for the costs, you have here the distribution for all the KPIs. Start date, finish date, duration, cost. Of course, start date is fixed. It's the whole project starts on the date it starts. But for the cost, there's an uncertainty range here. Now we could look at other things such as, earthworks. Let's take a look at what this looks like. Or we saw one that was pretty heavy on risks. It was structures assembly or fabrication. I don't remember. Well, let's take a look at earthworks. This one has a very long tail. It should cost 600 according to our best estimates, our deterministic model. And we see there's only a 38% probability that it will cost this or less. If you want to have a decent budget, a realistic budget for this, it should be 690. That's like 15% more, right? There's a 90% chance you'll spend up to $690,000. So that's a more realistic target for this specific budget for this contract, for example, okay? Why? Well, because of the many things that may occur here, of the many things that affect, many risks that affects this thing. Same thing for the finish date. It's very unlikely we finish when it was planned. We need some extra time. So now here we start talking about contingencies. So if it's important to deliver this earthworks execution for your project, you should not aim for July. You should actually aim for September. So 2 months, or actually, 70 days almost, right? Around 70 days in contingency here. to go from the deterministic very unlikely situation to a realistic P90, 90% chances you finish before this deadline. So if there's anything you do after that requires equipment, expensive services, etc., aim for this date, because otherwise you spend more money than needed. You have the resources available and not use them because you're not finished yet, for example. Actually, you could come back to your deterministic model and assign whatever task comes afterwards, comes after earthworks. Actually assign this task as a don't start before, put a constraint on the start date of the next task to make sure that you don't start it earlier, to make sure that you don't spend money or resources before you need them. That typical trade-off of cost versus schedule that we face when managing projects, right? So from the risk analysis result, you can assign better contingencies, you can control better, and you can actually plan better, change your base case to account for the risks or to react to the risks, okay? Now here, so we have all the distributions, and both in terms of histogram and also the cumulative curve for whoever prefers that way. There's also a report button that we have here on the analysis tab. This report button creates a summary of everything we're going to see from this point on, all the reports that we have, okay? Distribution graphs, cumulative curves, etc. Okay? Moving on through the results, we can look at what are the key risk drivers of your project or of any individual tasks along the way, okay? What are the key risk drivers, both in terms of finish date, cost, what are the risks driving your cost? What are the risks driving the finish date of your project? So risk number one, critical equipment problems on task 138. That's the critical risk, the most critical risk we have. Then risk number one, affecting something else. Well, it's not on the list. Permits affecting 115 is also here. And risk number two, permits affecting 122 is also here. So see, risk number two may affect two different tasks independently, and both are here. A very important risk. On the other end here, looking at activities, what are the activities that drive your finish date or your cost, or even better, cruciality? What are the activities that appear on your critical, critical path? So some activities, they have a cruciality of 1. They appear on the critical path 100% of the time, basically. Some activities have a cruciality that's a little bit slower, a little bit lower. So lower means it's not on the critical path all the time, but often. And then some activities are not that critical for the critical path. So different ways you can present information and make decisions based on this, okay? So there's a lot of stuff packed here. Moving on again real quick, sensitivity analysis. Now, the natural extension of knowing what are the key risk drivers is trying to contain them, trying to control them somehow. But what would be the benefit, for example, of, let's say, removing risk 2 from the game? If you could guarantee the permits, or if you could start the permits 1 year earlier to guarantee that they're not going to be delayed, what will be the benefit of that, of eliminating that risk, for example? This is what this sensitivity analysis charts do for us. So I'll focus on the P90 here, just for the sake of the exercise here. Let me calculate this real quick. What the sensitivity analysis will do here, it will remove, to run the analysis of everything, and then remove one risk individually for us to see what happens with the project. So for example, I have the project here, the cumulative curve of the whole project. This is the finish date of the project, okay? The finish date of the project has a P90 of whatever the date is here, March 2028. Remember that deterministic was somewhere in October 2027, very likely. If I remove risk number 2 here, this one, what happens with my P90? Well, my P90 drops from somewhere around, this is March, right, to somewhere around late February or mid-February. So February 15th, this is what it is. So if I can solve this problem, I actually save 20 days on my P90, more or less. You see, there are 2 other risks that save even more time. If I reduce the efficiency, or if I remove the inefficiencies of high variability tasks, which is very unlikely, I would say 40 days. So I'm not going to count on that. If I could solve the critical equipment problem, I would actually save more. I would save 25 days. So those are the two most critical risks that I have that would save me time based on P90. If you were looking at, let's say, P50, the situation is different. If you're looking at P99, the situation might be different, okay? So depending on what your KPI is, on what your objective is, some risks will be better than others to mitigate. And this is a point of view, a very simple, straightforward, easy to understand point of view. If you mitigate this risk, if you limit this risk, this is the benefit you get. You could do that for cost too. You could do that for the whole project. You could do that for specific tasks. Okay, so there's a lot of flexibility here on how to present this. But this is a very interesting idea. There's also besides the single pass, you can also do this for multiple risks together, so groups of risks, which is the multiple pass analysis. But this one here is very intuitive. I think it answers a lot of good questions. So which are the risks that we should focus on? How much benefit do I get if I fix them completely? Okay. We also have scatter plots that we could analyze this behavior straight up between cost and schedule. So if you take longer, you cost more, how likely is it that you finish within budget, within deadline, within both? You could see all that, okay? A very quick analysis here. The deterministic case is very unlikely to be achieved, right? So instead of that, let me add here, let me say that I would like to finish the project still in 2027. So how likely is that? There's only 8% chance that I'll finish within this, here. It's almost 50% chance that I'll finish here within this deadline, okay? But what about finishing within the deadline and also within my budget? I'm not going to use the deterministic budget. Let's suppose we have some allowance and I'm going to the budget with contingency. Let's suppose we have 2 million in contingency, so 54 million will be our budget with contingency. The likelihood that we finish within budget and within deadline is 22%. The likelihood we finish the project within budget, but still missing the deadline is a little bit higher. It's almost 50%, it's 45%, okay? So here with this scatter plot, you can check what are the conditions or based on your targets, what's the likelihood that you meet one target, the other, or both in terms of schedule and cost, okay? This is what this joint confidence level shows you, okay? We also have probabilistic cash flow, critical path, and many other analyses we could, present. But the most important by far is understanding the risk profile, the likelihood to meet your deterministic or whatever deadlines you have. You could set a target here manually for your project if you wanted, okay? The contingencies that you need to apply to your project, that you need to fight for, both in terms of time and cost, and the connections between tasks. What are the tasks that drive the tasks and the risks that drive your cost, that drive your schedule, so you can focus your meager resources, human capital, on controlling them, influencing them, or eliminating those risks, okay? Understanding all of this helps you both plan better, control your project, and deliver with more confidence, okay? Here we have mapped many risks that relate to schedule and cost. I mentioned that in data centers, we also have risks related to image, which are really important. Of course, we're not quantifying them here. You could be quantifying risk related to image if you wanted. It would require some qualitative approach to that, but the software could also work with that. Now, communities, image, they may create new risks here for your list. For example, you could have some kind of demonstrations in front of your data center because whatever water use it will create. This is starting to become common in some other countries, not here in Brazil. I think in Brazil we are very privileged in terms of both the resources and the regulations and the way that the companies build their data centers. But in other countries, you know that water is a real problem. So you could face demonstrations that could become a risk here in terms of schedule and cost, for example, okay? Now I'm going to wrap this up, and if we have questions, we could open
Hi, Rafael,
for questions now.
Let me. I was trying to answer all of this, but we had a couple saying that is there any reason why you prefer, or maybe you prefer use the standard risk type and for weather risks and not the calendar one, or maybe this was like a one only situation. I think that you're muted, Rafael. You're silent. Not sure
sorry.
what
Very
no
good
worries.
question. I don't know who asked about this one, but it's a very good question. The software can do both, and of course, it's more elegant to model calendar risk within the calendar tool, right? But it requires some extra maturity. So if you're starting, if you're working, if your PMO, or maybe your company doesn't even have a PMO, if you're working with a company at the lower end of maturity for risk analysis, on the qualitative discussions, people will probably bring the weather as one of the risks, but you will hardly find any data or evidence that one month is different from the other, or it will be easy to agree that there's a likelihood that we could face weather problems. We don't even detail what the weather problem is, but we could agree on a number, right? And then bring that as a standard risk. It's very easy to put that up as a standard risk on your matrix. And that brings you from nothing into something really good already, right? Now, if you're dealing with a mature environment where, let's talk about offshore oil and gas, for example, offshore drilling for oil and gas, where the weather is known, it's predictable, they have historical data regarding waves and wind conditions. We know what are the months of the year where it's worse or better. They have historical data to come up with a probability that you would face a problem in January, February, March, etc. So with that maturity, it's much better to use the calendar tool, where we can actually specify the likelihood of the event through blocks around the year. So you could have let's say in the summer, a block of bad weather, and then it means there's a 10% chance that you will not work on a given day. And in the winter, you have a block of bad weather with only a 2% probability, for example. So it's very easy to do that on the calendar tool. But to use it, which is way more elegant, I would say, to use it, you require a little bit more data or a little bit more understanding of the process. Being able to do all of that with a single standard risk, probability, and impact is already very good. You move away from darkness into shedding light on the problem somehow, right? But of course, it can be improved. So very good question. Thanks for that.
Good, and there was another one, and maybe it's because I tried to answer that, but I wanted your opinion as well. And thanks everybody for staying, because I know that we're like 5 minutes on top of the hour, so it will be this and another one. It's if you prefer the triangular to the trigen distribution, or you used it just because it was the default.
Also, good question. I don't really like the triangular. Don't have any kind of preference for it. I use the triangular and the PERT a lot, triangular and PERT, when we're dealing with 3-point estimates, right? The trigen brings you an extra layer of information, which is the likelihood that you would exceed that number. But what I see in practice is that when people, again, maturity, right? The maturity of the process. When people are professionals that are starting to work with risk, they tend to be very conservative, naive with their ranges. So you ask an engineer about the variability of a given task, he's going to tell you plus minus 5%, plus minus 10%. But when you look at data, like real data, we see that things deviate 50, 100% from what was estimated. Small things, right? Well, actually, I'm talking about schedule. Even the big thing deviates a lot, right? The whole project. So what happens is that when people are not accustomed or they're starting to work with risk, we tend to be very conservative with the ranges, tight, timid, I would say, shy with the ranges, right? And then in that case, I tend to use the triangular, at least to give some extra weight to those shy ranges. When we start getting more maturity with this, more familiarity, we start looking at the numbers and we see that things sometimes deviate a lot. then the triangular adds too much weight to that plus 50, plus 30%. In that case, I usually use the PERT because it goes to your maximum, but it goes with a very small likelihood. So you have both the benefits of including the extremes on your model, the long tails that could happen, but with a low likelihood, which is usually what happens with the long tails. Long tails are usually kind of a log-normal thing, right? You have a center, a normal center of things, and a long tail to the right when things deviate too much. Now, I tend to use the PERT more often. I don't use the trigen too much, or at least I don't propose it, because we're still with the triangular, and I would like to go beyond that. And it requires a piece of information that if you are using the triangular due to this maturity issue, you don't have that information. So I would rather use the PERT, if I could, than the trigen. Okay, and just stick to the typical triangular if it's what we have. Okay. Now that said, the important thing about the tails too is that sometimes that tail you observe is not the variability, but it's the effect of an external risk happening on top of your variable, right? The variable that you are observing, the data that you have, let's say offshore drilling times, it could be because of the natural variability and the tail happening sometimes because of the occurrence of an event. Okay, so those two things, sometimes they get mixed on the data set. We can break them apart and model them separately in the risk register.
Thank you, Rafa. And the last one, it says from Chad, he says, if I'm just getting started with Safran risk, is it a good practice to, or maybe you can create a generic risk that can be loaded for all the activities, like a stress test, if it's something that you normally would do?
Yeah, the two things. Well, the variability itself, the uncertainty, the estimate uncertainty type of risk is this. You can apply plus minus X% to everyone, right? And one thing we see sometimes people do when you want to really focus your time, sometimes people ask themselves, where should I focus my time? Which kind of risks should I focus my attention to? Or which tasks on my project should I spend more time figuring out the risks that are around these tasks, right? So one thing sometimes people do is you create one general risk like minus 50 plus 100% for everything. You run your model with that single big gigantic risk. And then when you look at the end of the cruciality, you will see that some tasks, they are on your critical path most of the time. Some tasks, they are almost never on your critical path, and some of them are never, ever on your critical path. So you should focus your risk analysis efforts on understanding these tasks at the top, and then figure out which risks from your environment could affect them, and then modeling those. I mean, that would be the prioritization of your available time as a resource, right? As a modeling resource. Sometimes people do that. But answering her question straight away, that's what we usually do with the variability. We assign one big variability to everything. One small variability to represent our lack of control on top of everything. And sometimes, most of the time, a second level of variability just for the specific things that we know may deviate more or that are more complex or less with a less accurate estimate to begin with, okay? So those two, apply those to the whole model usually, okay? Either of them, but the whole model will be affected by either of them. And then, of course, the events, they are specific to single tasks or 2 or 3 tasks at a time. I hope to have answered the question.